Hello students, welcome to the chemistry class. Today we are going to continue with the fourth chapter, that is atomic structure. So today we are going to discuss about the Ernest Rutherford's model of an atom. As you know that J.J. Thomson had proposed a model of an atom, but his former student Rutherford had conducted a lot of experiments to explain the structure of an atom, and he proved that the model which was suggested by J.J. Thomson is incorrect. Rutherford performed a lot of experiments which led to the discovery of nucleus. So the Rutherford's alpha ray scattering experiment is very important, and we are going to discuss this. For this, the alpha particle we are going to discuss, it is the two protons and two neutrons. It is actually the helium ions, and they are very tiny, and each alpha particle carries a mass of 4 units. So the discovery of nucleus. He took a gold foil which is very thin, and radioactive source is providing the alpha particles. Polonium is used as radioactive, and zinc sulfide is used to detect the deflection given by the alpha particle. He observed that the most of the alpha particles pass straight through the gold foil undeflected, and a small number of alpha particles were deflected at small angles, while some were deflected at the large angle. A very few alpha particles bounced back just like a ball hitting a wall. So the observation is that most of the alpha particle could pass undeflected through the gold foil you have seen. And the second is some alpha particles were deflected slightly from their path. We have also seen a very few alpha particles were deflected by a large angle or bounced back from their original path. So let's have the internal view that what is actually happening inside the atoms. So you can observe that most of the alpha particles are passing straight, a small number of alpha particles are deflecting, and a very few are bouncing back. So the conclusion is there is a large empty space in the gold atom, due to which most of the alpha particle could pass undeflected through the gold foil. Now here you can observe that a particle which is passing very nearly from the nucleus is showing the small deflection. This is due to the positive charge repel each other. So the central part of the atom is heavy and positively charged, due to which a very few alpha particles suffered deflections as like charges repel each other. So the alpha particle which was very close to the nucleus shows the deflection. The alpha particle, which is exactly striking with the nucleus, is bounced back, which shows that central part is hard and dense, and the small as compared to the size of an atom. So the third point, the central part is very heavy and dense, so a very few alpha particles retrace their path. So we have found that the nucleus of an atom is very small as compared to the size of the atom on the whole, and secondly heavy and positively charged, and the third one is it is very dense, hard and rigid.